For this week on CyberSchool, we're going to get back into our series about talking about SIP and multicast. And this week, we're going to focus specifically on SIP and, really kind of explain it in a little bit more depth and just talk a little bit about how to use it. This is a very important protocol that's used in VoIP and the telecom industry as a whole. And it's really important to have some kind of a base level understanding in it. It's a very deep say rabbit hole that you could get into if you really want to learn all the specifics. But just having a cursory or basic understanding of what the protocol is can be very powerful as you're learning and trying to adapt different equipment for specific use case. So first off, what is SIP? SIP, or Session Initiation Protocol, is basically a protocol that's used to go and set up different phone calls between devices. It's used to, by the RFCs, or the standards that dictate, the rules for the internet. It's a multimedia protocol used to set up some kind of media transport, which could be video, audio, video and audio, text, what have you, but it's predominantly used to set up phone calls. That's kind of how it's been adopted, which makes it, basically the main protocol that's used by the wider VoIP industry. So when you're dealing with different providers out there, Zoom, RingCentral, AT&T Office at Hand, 3CX, Sangoma, FreePBX, Cisco, what have you, they're pretty much all using SIP now. There were some older protocols that, kind of had a little bit of a foothold in the industry in years past, but, now SIP is kind of the de facto standard, and even the major manufacturers that were utilizing some of those other protocols have switched to making everything SIP compliant, just because it's easier and it makes it more adaptable and interoperable with the rest of the industry as a whole, which kind of makes it the industry standard for making and placing a phone call. So how does this all work? Now that we understand what SIP is, well, the way that it works is, we'll basically walk through one kind of a setup for, how SIP actually sets a call up. And we've got two people, Alice and Bob. And Alice wants to call Bob. And just some pre-context, of course, both Alice and Bob are going to be connected to an IP PBX server. It could be the same one. It could be two different ones. That part, honestly, is not important for the discussion at hand. But basically, Alice wants to call Bob. And how does that process actually work? Well, when Alice picks up her phone and tries to actually make a call to Bob, she dials Bob's extension number or Bob's phone number. Alice's phone is actually going to send a SIP message off to a server. The server receives that, processes the message, and realizes that it's intended for Bob, and sends that message over to Bob. So it kind of creates part of a triangle where Alice's message goes to the server and then to Bob. So then Bob's phone starts ringing. So Bob answers the call. And when Bob actually picks up his handset, it sends a message back to the server, basically that says that, hey, the call has been connected. So then the server, playing the middleman, lets Alice know that Bob has answered his call and connects an audio path between the two. Sometimes that audio path goes through the server. Sometimes that audio path is directly between Alice and Bob. It varies depending on the provider that you're working with, network constraints, what have you. There's a lot of other factors that can determine if the audio is routed between Alice and Bob directly or between Alice, Bob, and the server. It kind of depends. But at a very high level, that's how a SIP call works. Somebody wants to call somebody, and the device, the endpoint, the phone, the program sends a message to the server to contact that particular person that they're trying to contact. When the other person answers, again, on their phone, device, endpoint, program, what have you, a message is sent back to the server, and both parties are connected and calls and audio can flow. But with that, we've talked a lot about how it works and how messages get, actually go from, Alice to Bob, from A to B. There's some stuff underneath the hood that actually makes SIP very powerful in terms of getting those messages between Alice and Bob. And that comes down to the different transport protocols that are used to basically get the message from A to B. And an easy way to think about it is, kind of like all the different delivery options that we have here. You've got companies, of course, like the USPS, the US Postal Service, you've got FedEx, you've got UPS, you've got DHL, what have you. There's a lot of different transport companies to get something from point A to point B, and SIP has similar transport protocols that it can use to get those messages from point A to point B. And there's basically three different variants. There's UDP, User Datagram Protocol, TCP, Transmission Control Protocol, or TLS, Transport Layer Security. Now, these three different options, there's different use cases for specific ones, but really UDP has kind of been the industry standard. That user datagram protocol has been the industry standard basically since the start of VoIP, and is only now starting to get its lead eaten up by the other two options. It's still widely used across the industry and is honestly kind of the standard with most providers that you're working with. But TCP and TLS is becoming more and more standardized. And one of the reasons that UDP's lead in the industry has kind of been eaten up is, and this even started pre-pandemic, is with everybody moving their phone systems to the cloud, of course, brought on by, very large providers such as, RingCentral, Zoom, some AT&T, even some Cisco offerings, with stuff hosted in the cloud, and your call traffic and your audio going across the open internet makes it, a little bit more important to secure that data. Because say if you're, some big CEO of, some venture 500 company, and you're calling another very important CEO, you don't necessarily want people to be able to spy on the traffic and know that these two CEOs that are, battling out some kind of a cola deal or what have you are talking to each other. You really wouldn't want that kind of information to go out. And because it's going out across the open internet, somebody could potentially sniff that traffic and get a way to spy on it. So TCP and TLS have become a little bit more important in the industry as a whole, because TCP is kind of the other transport protocol. It's predominantly used with TLS, which is kind of becoming a almost de facto standard for hosted providers, just because that actually encrypts the setup messages, the SIP messages between point A and point B, so that way nobody can spy on that as it's going out across the open internet. That way it's kind of sealed. The package is sealed. It's got that, little wax stamp on the back of it, and that somebody's, potentially tampered with something, or it's all encrypted. So, they wouldn't be able to do that. But there's multiple different transport protocols that are used by SIP. Some have some advantages and some have some disadvantages. And we can kind of get into that after we talk a little bit more about where SIP is used. So, of course, SIP is going to be the standard protocol that's used by all different phone systems out there. Predominantly, there are still some old stickler ones that don't use SIP, but I'd say 95% or more of the greater VoIP industry is going to be supporting SIP. And that means, of course, any endpoint or accessory style devices, your standard desk phones, and then the soft clients or programs that we've all started to use, through the pandemic with, clients such as Teams or RingCentral or, WebEx, what have you. The multitude of different clients that we use that also have some kind of a phone built into it are all going to use SIP to set up those messages. So it's widely used across anything that you're going to use in the telecom industry or with your VoIP phone system. Which makes it kind of an industry standard, again, for setting up all the phone calls. There are other protocols out there, but the SIP has the absolute lion's share of setting up all of these different phone calls. But when you're dealing with setting up phone calls, there's really two different styles that you can use. You've got the person-to-person style, again, the Alice calling Bob or Bob calling Alice, person-to-person style calling. But then there's also use in the paging context, where you want to send a message out to say Alice, Bob, Joe, and Jeff. You want to get a message out to multiple people at once. And instead of using SIP to just make a phone call to Alice, to Bob, to Jeff, to Joe, 4 calls, you can do a one-way page. That way everybody gets that message simultaneously. So you'll have SIP used under that context in some scenarios, but not all. And there are some potential pain points that we can get into with that. So with that, we kind of have some pain points when we're dealing with SIP, and because not every protocol is going to be perfect on its own, and we can kind of talk a little bit later as we get into some different sessions about how to counteract some of these pain points. But some of the big ones when dealing with SIP, especially just because of the nature of how everything works now, is SIP works all well and good when it's in your local area network, but say you want to call somebody's cell phone, or you want to call another provider, or you're trying to set up some kind of a meeting with somebody, that has to go outside of your network. So it has to go through a firewall and has to potentially enter their firewall. So that creates some potential pain points there just with network setup and network configuration that, SIP can run into a lot of issues with. It's definitely something that we encounter on a relatively regular basis in our tech support department, as does every major equipment manufacturer or every major phone system provider. Everybody runs into some kind of network related issues, specifically regarding around a firewall, which is why you'll find that every major phone system provider has a list of ports and best practices and things to do with your network firewall when you're using it with their platform. So it's just kind of a known pain point that you're running into with SIP. Also, you get the paging, that I kind of alluded to in our last slide there, that can be potentially an issue. Where paging with SIP is very powerful when it's used at a smaller scale, say 5, maybe 10 people at most, because the way and the nature of the SIP protocol, it sends a message to each person individually. So if you're thinking about it, that connection, again, alluding back to our Alice and Bob have to both connect to a server. And so we've got Alice, Bob, Joe, and Jeff, 4 different people that all need to get, the same message at the same time. That's 4 simultaneous connections to the server. So that eats up some of your network bandwidth. And that's only at 4. And if you scale it up to, say, 50, 60, 100 people, that's a lot of connections to a server, and that can eat up a lot of network bandwidth. So it makes paging via SIP really not ideal for extremely large-scale scenarios, and paging in general, because generally when you're dealing with paging, you're going to be dealing with a higher number of endpoints, sometimes 50, 100, sometimes even 200 is, not abnormal when you're dealing with, say, a large school campus or a large hospital building or what have you. Sometimes there's a lot of endpoints that need to play a message, and when dealing with that kind of scale, SIP is not ideal for something like that. And then finally, sometimes when you're dealing with different transport protocols, there can be some issues that you run into, just down to how those transport protocols work. And that's really a whole nother rabbit hole that we can get into that we're not going to go into for the purposes of today's video. But some network or some transport protocols don't work as well with network firewalls as others, just because of the way that those protocols are designed. Whereas there's certain protocols, such as TCP or TLS, both transport protocols, that work a lot better with network firewalls as compared to UDP, just because of the nature of how those protocols are designed. So there's specific pain points that you can run into that you can alleviate by pairing SIP with another popular protocol, for lack of a better term, multicast, to be able to kind of counteract some of these pain points of SIP. And we'll get into that in another session, as we still have to talk about multicast a little bit more, and we'll do that in next week's session. So finally, when we're dealing with SIP, it's going to be widely used in the telecom industry. It's kind of become the de facto standard. And if you're dealing with anything that is phone system related, it's going to be using SIP more often than not, which makes it kind of the industry standard when you're going and making a phone call, whether it's just from Alice to Bob, or you're calling, your wife at home to let her know that, you're going to be a little bit late for dinner or what have you. That's all going to be using SIP. And depending on the provider that you get your VoIP contract from, some will actually support SIP in the context of paging. Not all do this, and there's a lot of limitations that are built in with these SIP paging capability. Can be very powerful in a small subset, in a small instance, but when done at scale, it really doesn't make sense, which makes SIP a really powerful a protocol that you can utilize, but it's not perfect. And you can run into different issues, especially when dealing with network firewalls. But when you pair it with another protocol, such as multicast, it makes it extremely powerful, and it shows why this has become the standard for the VoIP industry.
Thank you for watching this edition of CyberSchool. If you have any questions, please get in contact with our sales department. They are available by email at sales@cyberdata.net or by phone at 831-373-2601 extension 334. Please make sure to like this video and subscribe for more content like this from CyberData.